Okay, in section 12.6 we're going to be looking at some ideas involving what we call regression lines. We're going to start out with talking about a scatter plot. Ultimately, one of the things that we do in life and in mathematics often is to collect data, and when we collect the data we generally put it on a graph. We call that a scatter plot. Right? Ultimately, we can use this scatter plot to determine if there is any kind of relationship between two quantities. Okay, so if there is this idea of correlation, there's going to be a clear relationship between the two quantities. Okay, and ultimately we're going to use that to determine this relationship, okay, between these two variables, and if so, the strength and the direction of that relationship. So those are the things that we're going to be looking for in terms of what we call correlation. Okay. So let's start out by looking at a scatter plot here. There's one given here. The scatter plot shows a downward trend among the data points with some exceptions. Okay. If we were to plot these points, looks like we go from 4 years of education to a score on a test measuring prejudice. We have 10 here. We have 5 years of education. We have 7. Okay, and there seems to be a relationship here with the number of years of education going up, that the test measuring your score on, in terms of prejudice, going down. Okay, so the trend here that we're seeing is that people with increased education tend to have a lower score on this test measuring prejudice. Okay. Now, a couple important ideas here involving correlation and connections here. It says, although the scatter plot shows a correlation between education and prejudice, we cannot conclude that increased education causes a person's level of prejudice to decrease. And the key word there is the causes. Okay? We can't assume that that is going to cause a person's level of prejudice to decrease. Okay? The correlation could simply be a coincidence. That's one option. Okay, education usually involves classrooms with a variety of kinds of people. Increased exposure to diversity in a classroom might be the underlying cause. Education requires people to look at new ideas and see things in different ways. Thus, education causes one to be more tolerant and less prejudiced. And again, these are some possible connections here relating to that particular graph that we looked at. Okay? But again, keep in mind that we can't assume that that's a cause. Now, what we generally like to do with a scatter plot is, if the scatter plot is fairly linear, kind of like that last one was, okay, we like to draw a regression line that best fits those points in the scatter plot. And ultimately what we want to do in math is take that regression line and use it to make predictions. Okay? So there's lots of applications in science and business, etc., where if we collect data, we want to use that data to generally drive, again in a business situation, we want to collect data to hopefully maximize our profit, and we might use mathematics to figure out how to do that the best way. Okay. Now, when we have data in a scatter plot, we can generally find what we call a correlation coefficient that we usually call R. Okay, that's used as a measure to describe the strength and direction of the relationship between the variables whose data points lie on or near a line. Now, I want to point out a couple things here. Number one, the first thing is that when we're talking about this, we're talking about a line. Okay? So when we talk about a correlation coefficient, we're talking about linear regression. Okay, if we plotted the points and they did not look like they were on a line, then we would not use linear regression. So the work that we're going to do in this class is primarily going to be using linear regression. Okay, so ultimately we have a few different things we can say here. The relationship is positively correlated if they tend to increase or decrease together. Okay, negatively correlated if one variable tends to decrease while the other increases. Okay. Perfect positive correlation in which all the points lie precisely on the regression line that rises from left to right, and perfect negative would be that all the points lie on the regression line that falls from the left to right. Now, let's take a look at some pictures, because the pictures are the best way to illustrate that. Okay, in the case of A here, this is a perfect positive correlation. All these points lie on exactly the same line. Okay, this is a strong positive correlation, and I want you to notice the R values that are attached to these. The highest R value we can have here is 1. Okay, that's the biggest R value we can get. Okay, that means it's perfect positive correlation. If the R value is fairly close to 1, okay, we say it's strong positive correlation. Okay, if it looks like they're kind of going up, but they're not really together very well, okay, we call that moderate to weak positive correlation. Notice the R value of 0.3. If they're all over the place and make no line whatsoever, then we would say that it's a no correlation situation, and the R would be 0. Same thing going backward in the negatives. If we have data that seems to be going down but is not very close to a line, we would say it's R equals approximately -3. It's moderate to weak negative, and then strong negative, and then finally perfect negative. And notice the perfect negative has a -1 as the R value. So the closer to 1 we are, the better the correlation. The closer to -1 we are, the better the negative correlation. Okay. All right, now this looks like a really fun formula. If you take a look at it, the following formula is used to calculate the correlation coefficient R. And if you look at that, that looks like a big mess. Okay? And it is. And therefore, we're not going to do that in this class. We are going to use our calculators. Since we all have graphing calculators, we're going to use the calculator to calculate the correlation coefficient. So let's take a look at the data that we're given here. We have years of education, scores on the prejudice test. Okay, same data that we looked at earlier in graph form. I'm going to go ahead and turn my calculator on. I'm going to hit stat, which is right here, edit, and then I'm going to put this data in there. So I have 12, 5, 14, 13, 8, 10, 16, 11, 12, and 4. And then over here on this list, I'm going to put my y coordinates, if you will. 7, 3, and 5, and 4, and 1, and 2, and 3, and 10. Alright, and a couple things that we can do here. We know we can draw it. We can actually draw this with a scatter plot. If we do above our y equals, we have stat plot. So I'm going to go ahead and turn that on because I want to see what this scatter plot looks like. So we'll turn that scatter plot on. And it's already on scatter plot. My top left corner is the right type. I got list 1 and list 2 are where my data is. My mark, I like to draw the square because you can see it better. And then the other thing we have to make sure is that in our window, and we want to make sure that our window, we have numbers that are as big as 16, that is, and as small as 4. So I'd probably go from 0 to 20. I want to have it smaller than the smallest, bigger than the biggest in that direction. And in the y direction, these are our y coordinates. We go from 1 to 10, so I'd probably go, let's say, 0 to 12. And if I hit graph, I'm going to first turn off what I have in y equals so it doesn't graph any curves that I already had in there. And I'm going to go ahead and hit graph, and I should see that scatter plot just as such. Okay. Now, ultimately, what I want to do is I want to compute the correlation coefficient for that. But to do that, okay, I would have to go through that messy formula, which I'm not going to do. Okay. And we ultimately can use that to write the equation for the regression line. Now, they got, at the final verdict for them, they got the regression line of this. They didn't tell you the correlation coefficient yet. We'll get to that in a minute. But ultimately, I'd like to be able to write the regression line for this, the line of best fit, the line that goes through those points the best. Okay. So to do that, again, it's a calculator problem for us. We're going to hit stat, calculate, and number 4, you have ln reg. And you notice it's of the form ax plus b, which for us has generally been mx plus b, but the a stands for the slope nonetheless. So if we hit the regression line, and what's nice about your calculator is not only can we get the regression line, but we can also get the correlation coefficient all at the same time. Okay. So if I hit my ln reg and hit enter, okay, there you can see negative 0.687x plus 11.011, and that would be our regression line. And notice that the R value here is negative 0.92, which is fairly close to -1, so that means there's a pretty strong negative correlation. Okay, and that would do it. Okay, so if you have your calculator, this is a pretty easy process. We can find not only the regression line, the slope and the y-intercept, to put it in there for our regression line to use to make predictions, but we can also find the correlation coefficient without having to do that messy formula.